My name is Kevin Kircher. I'm an assistant professor in the Department of Mechanical Engineering at Purdue University. So heat pumps are efficient electric machines that can heat and cool buildings. So heat pumps work by moving heat from a cooler region to a warmer region. So in summer, for example, a heat pump operates basically like an air conditioner. It absorbs heat from the cool indoor air and moves it to the hot outdoor air. In winter, a heat pump just operates in reverse. It absorbs heat from the cooler outdoor air and moves it to the warmer indoor air. And because heat pumps use electricity to move heat, or pump heat around, rather than converting it directly into heat like an electric resistance or a baseboard strip heater would, heat pumps can be several times more efficient either than electric resistance heating or than fossil-fueled furnaces or boilers. So heat pumps are a climate change solution basically in the same way that electric vehicles, cars and trucks are. So they allow us to avoid burning fossil fuels on site and provide a valuable service driven by clean electricity rather than that fossil fuel combustion. So in much of the United States, the electricity mix has gotten substantially cleaner over the last 10 to 15 years, driven primarily by natural gas power plants and also wind turbines and solar panels replacing coal-fired power plants on the grid. So as electricity has gotten cleaner, the potential emission reductions from heat pumps have gotten better. And I showed in my PhD research that on average over the United States, heat pumps could reduce greenhouse gas emissions from space heating and cooling by about 1/3. And that those reductions in regions with very clean electricity can be as high as 90%. So heat pumps work by what's called our vapor compression cycle. So they run a refrigerant, which is a carefully chosen mix of chemicals, through a series of physical processes. That starts by compressing the refrigerant, which raises its temperature, making it very hot. The refrigerant then flows through what's called a heat exchanger, basically a series of coiled pipes, where the very hot refrigerant gives up some heat to the indoor air. It then flows through what's called an expansion valve, which reduces the pressure and crucially makes the refrigerant very, very cold. And then it flows through another heat exchanger outside where that very cold refrigerant absorbs heat from the outdoor air. And then the refrigerant goes back to the compressor and that cycle repeats.